Pork is more than just a food in China. It is a thread woven deeply into the fabric of culture, family, and the national economy. For generations, the aroma of red braised pork, or hongxiao rao, has signified celebration, comfort, and prosperity. It graces tables during the Lunar New Year, anchors family dinners, and serves as a staple protein for hundreds of millions of people daily. This profound cultural significance, however, is now intertwined with a growing environmental reality. As China's population has grown and its economy has boomed, the demand for pork has skyrocketed, transforming traditional small-scale pig farming into a massive industrial enterprise. This essay seeks to map the environmental cost of this system, specifically its greenhouse gas emissions. The journey of pork from a simple farm animal to a staple on the dinner plate is a long and complex one, and every step leaves an environmental mark. This system, known as a value chain, begins long before a pig is even born, with the cultivation of massive fields of corn and soy for feed. It continues on the farm, where pigs are raised, and then moves through a network of transportation slaughterhouses, processing plants, and retail markets. Finally, it ends in the kitchens of consumers, and eventually, as waste. Understanding the greenhouse gases produced at each of these stages is crucial for grasping the full climate impact of one of the world's most significant food systems. The production and consumption of pork generate a cocktail of potent greenhouse gases, each with its own unique source and warming potential. The three primary culprits are carbon dioxide, methane, nitrous oxide. Carbon dioxide is the most well-known, primarily released through the burning of fossil fuels for energy and transportation. It is the baseline against which other gases are measured. Methane is a far more powerful, though shorter-lived, greenhouse gas. Over a 20-year period, it is over 80 times more potent at trapping heat than carbon dioxide. Nitrous oxide is even more formidable, with a warming potential nearly 300 times that of carbon dioxide over a century, and it can persist in the atmosphere for over 100 years. To manage and mitigate these emissions effectively, they are categorized into three distinct scopes by international climate accounting standards. Scope 1 covers all direct emissions from sources that are owned or controlled by the entity in question. For a pig farm, this would include the methane released directly from the pig's digestive processes, enteric fermentation, and from the decomposition of their manure. Scope 2 encompasses indirect emissions generated from the purchase of electricity, steam, heating, or cooling. The carbon dioxide released from a coal-fired power plant to supply electricity for a slaughterhouse's refrigeration systems falls squarely into this category. Scope 3 is the broadest and often the largest category, representing all other indirect emissions that occur in a company's value chain. This is the everything else bucket. The pig farm itself is a significant source of direct or Scope 1 greenhouse gas emissions. The most substantial of these are methane and nitrous oxide. Both are primarily linked to the management of animal waste. A single pig can produce several kilograms of manure each day. When that waste from thousands of animals is collected, it becomes a powerful chemical reactor. In many large-scale operations, manure is stored in liquid form in open pits or lagoons. In these oxygen-poor anaerobic conditions, specific microbes thrive, breaking down organic matter and releasing large quantities of methane into the atmosphere. Another major source of Scope 1 emissions is how manure is handled and applied. When manure is spread onto fields as a natural fertilizer, different microbial processes take over. Depending on soil conditions, temperature, and moisture, bacteria can convert nitrogen compounds into nitrous oxide, a highly potent greenhouse gas. The storage and application method, injected into the soil or spread on the surface, composted first or applied raw, dramatically influences how much nitrous oxide escapes. These emissions can be a significant part of a farm's climate impact. Other on-farm activities also generate Scope 1 emissions. Many farms need heating for farrowing houses. Burning fossil fuels like coal, diesel, or natural gas in boilers and heaters releases carbon dioxide. Farm-owned vehicles also burn diesel, adding to CO2 output. Life cycle analyses show on-farm Scope 1 emissions, especially from manure, can be a large share of the carbon footprint, often estimated at 30 to 45% of cradle-to-gate emissions. That underscores the need for better waste management. Technologies that capture methane from lagoons and convert it to biogas can turn emissions into energy, directly cutting a big slice of the farm's climate impact. Scope 2 emissions represent the greenhouse gases released elsewhere to generate the energy a facility buys and uses. In the pork value chain, these emissions peak after pigs leave the farm. Slaughterhouses, processing plants, large-scale cold storage facilities. These industrial sites are voracious consumers of electricity. Slaughtering and processing lines rely on electrically powered machinery for everything from automated conveyance systems, cutting, grinding, to packaging equipment. The sheer amount of electricity required is immense. The biggest driver here is refrigeration. From slaughter onward, carcasses must be rapidly chilled. Walk-in coolers, blast freezers, and refrigerated storage warehouses run 24 hours a day, 7 days a week. Emissions aren't produced at the plant, but at distant power stations, predominantly coal in China. The carbon intensity of the electricity grid is the critical variable for Scope 2. In coal-powered regions, a plant's Scope 2 footprint is high. In regions with wind, solar, or hydropower, it drops drastically for the same energy use. The path to cut these emissions, increasing the energy efficiency of machinery and refrigeration systems, and, most importantly, transitioning the national power grid away from fossil fuels toward renewable sources. Decarbonizing the power sector is a crucial enabler to reduce the pork industry's climate impact. Scope 3 is the catch-all category that often represents the largest and most complex piece of the emissions puzzle for the pork industry. These are the indirect emissions that occur up and down the value chain, outside the direct control of the pig farmer or processor. The single most significant component of Scope 3 emissions for pork is, overwhelmingly, the production of animal feed. Pigs are fed a diet rich in corn. Pigs are fed a diet rich in soy. The cultivation of these crops is an emissions-intensive process. The industrial production of nitrogen fertilizers is energy-intensive and releases CO2. When fertilizers are applied to fields, they release nitrous oxide, N2O. Machinery used to plant, tend, and harvest these monocultures runs on diesel, releasing more CO2. In some cases, soy fields came from recently deforested land in South America, causing a one-time release of stored carbon. Indirect land use change. Combined, feed emissions can make up a huge share of the product's carbon footprint, often between 30 and 50%. Much of pork's climate impact happens in a field, thousands of miles away before a pig is born. Transportation is another critical element of Scope 3. CO2 from trucks transporting raw feed ingredients to the mill, and from finished feed being hauled to the farm. CO2 from live pigs moved from farm to slaughterhouse. CO2 from processed meat shipped to distribution centers and retail stores. Given China's vast distances, the logistics network's cumulative emissions are substantial. Every leg adds to the carbon tally, powered almost exclusively by diesel combustion. Scope 3 extends to the product's end of life. Energy used by retailers, lights and refrigerated display cases, fuel used by consumers driving to the store, electricity or gas used for cooking the pork at home. It also includes emissions from waste. Pork thrown away at retail, restaurants, or homes typically ends up in landfill. There it decomposes like manure in an anaerobic lagoon and releases methane. Food waste is the ultimate inefficiency. All production emissions are squandered, plus an extra emissions penalty at the end. The detailed mapping of emissions from China's pork industry is not just an accounting exercise, it is a roadmap for action. Achieving carbon neutrality for such a complex system is a monumental challenge, but it is essential for both national and global climate goals. Food systems are responsible for roughly 1/3 of all human-caused greenhouse gas emissions, and as a dominant component of China's agricultural sector, the pork industry has a critical role to play. Reducing these emissions is a direct contribution to stabilizing our planet's climate and avoiding the worst impacts of global warming. For example, capturing methane from manure to produce biogas not only cuts emissions, but provides a renewable energy source for the farm, reducing reliance on fossil fuels and saving money. Improving feed efficiency so that less grain is required to produce a kilogram of pork lowers the pressure on land, lowers the pressure on water, lowers the pressure on fertilizer resources, reducing the overall environmental footprint, and making the system less vulnerable to crop price volatility. These are co-benefits that enhance rural livelihoods and food security. Ultimately, this journey matters because food lies at the intersection of culture, health, and the environment. As a consumer who appreciates the cultural role of pork, I believe it is possible to honor tradition while embracing innovation. The goal is not to eliminate a food that is important to so many, but to produce it in a way that does not cost the earth. By carefully measuring emissions, identifying hotspots, and implementing targeted solutions, China's pork industry can transition from being a major source of greenhouse gases to a model of sustainable agriculture. This path ensures a cleaner environment, a more stable climate, and a secure and healthy food system for future generations.